Hello, and welcome. Tonight, we'll be exploring what NASA has discovered at the edge of everything. At first, that may sound like a simple destination, a distant place somewhere beyond the stars, a final boundary where the known universe comes to an end and the unknown begins. But as we will discover, the edge of everything is not a single location. It is many places. It is many moments. And perhaps, most surprisingly, it is many different times. For as long as people have looked toward the horizon, we have wondered what might exist beyond it. Ancient travelers crossed oceans searching for the edge of the world. Explorers climbed mountains, hoping to see farther than anyone before them. Sailors followed unfamiliar stars into waters that seemed endless. Every generation inherited a horizon from the generation before it, and every generation eventually discovered that the horizon was not the end at all. It was simply the beginning of another journey. Today, our horizons have expanded beyond oceans and continents. They stretch across the solar system, beyond the stars, and deep into the history of the universe itself. Yet the feeling remains strangely familiar. The desire to know what lies farther ahead. The desire to understand where we came from. The desire to see just a little farther into the darkness. When people speak about the edge of the universe, they often imagine a giant wall or an invisible border, something that separates everything from nothing. But nature rarely works that way. The universe does not place neat fences around its mysteries. Instead, there are many frontiers. There is the edge of the observable universe, where the oldest light we can possibly detect is still arriving after a journey of billions of years. There is the edge of the solar system, where sunlight grows weak, and the familiar planets give way to frozen remnants left over from the birth of the sun. There is the edge of the sun's influence, where solar winds fade and interstellar space begins. And there is another frontier entirely, the edge of time. To understand that idea, imagine receiving a letter that has been traveling for many years. The moment you open it, you are not reading about the present. You are reading about the past. Light works in much the same way. Whenever you look at something in the sky, you are seeing it as it once was. The moon appears as it was a little over a second ago. The sun appears as it was several minutes ago. The nearest stars appear as they were years ago. More distant stars reveal decades, centuries, or thousands of years of history, and the most distant galaxies reveal events that occurred billions of years before Earth even existed. The farther away something is, the longer its light has traveled, and the longer its light has traveled, the further back in time we are looking. In a sense, every telescope is a time machine. Not a machine that carries people into the past, but one that carries the past to us. This simple idea changed astronomy forever. It meant that the night sky was not merely a collection of distant objects. It was a library of history. Every beam of light carried a story. Every galaxy preserved a memory. Every observation became a glimpse into a different chapter of cosmic time. Over the past several decades, a handful of remarkable spacecraft and observatories have helped humanity read those chapters more clearly than ever before. Among them are four of NASA's greatest explorers: the Hubble Space Telescope, the James Webb Space Telescope, the New Horizons spacecraft, and the Voyager probes. Each of them traveled to a different frontier. Hubble looked outward and revealed that the universe contained far more galaxies than anyone imagined. James Webb pushed even deeper, capturing light from some of the earliest known galaxies and allowing us to glimpse the universe in its infancy. New Horizons journeyed into the frozen outskirts of our solar system and transformed our understanding of Pluto, and the mysterious worlds beyond Neptune. Voyager traveled farther still, becoming the first human-made object to enter the vast region between the stars. At first glance, these missions may seem unrelated. One studies galaxies, another studies planets, another studies interstellar space. Yet together they tell a single story, a story about expanding horizons, a story about curiosity, a story about what happens when human beings continue asking what lies beyond the next frontier. There is another reason these missions fit together so beautifully. Each one reveals a different age of cosmic history. James Webb shows us the universe as it was near the beginning. Hubble reveals billions of years of galactic evolution. New Horizons studies ancient objects that have remained largely unchanged since the formation of the solar system. Voyager carries us toward a future in which humanity's first interstellar messengers continue their lonely voyage through the galaxy. Together, they form something like a timeline stretching across space. A timeline written in starlight, ice, dust, and distance. And as we follow that timeline, we begin to realize something profound. The edge of everything is not really an edge. Every time we think we have reached a boundary, another horizon appears beyond it. Every discovery answers one question and raises several more. Every frontier opens into a larger landscape. That may be one of the most beautiful lessons astronomy has ever taught us. The universe does not become smaller as we learn more about it. It becomes larger. And so, with that thought in mind, we can begin our journey toward one of the most extraordinary frontiers ever explored. Not at the edge of the solar system, not beyond the stars, but near the dawn of cosmic history itself, where ancient light has been traveling across the darkness for billions of years, patiently waiting for a remarkable telescope to receive it. When the Hubble Space Telescope first showed humanity the deep universe, it felt as though a great curtain had been pulled back. Suddenly, regions of space that once appeared empty were revealed to contain countless galaxies. Yet every answer seemed to produce another question. If Hubble could show us galaxies billions of years old, what came before them? What did the universe look like when the first galaxies were just beginning to form? How far back could we possibly see? To answer those questions, astronomers needed a new kind of telescope. Not necessarily one that looked harder, but one that looked differently. Imagine standing outside on a foggy morning. In the distance, you know there are trees, houses, and roads. But the fog hides much of the landscape. The objects are still there. You simply cannot see them clearly. Now imagine putting on a special pair of glasses that allows you to see through some of that fog. Suddenly shapes emerge from the mist. Details begin to appear. The world becomes larger than it seemed only moments before. The James Webb Space Telescope works in a somewhat similar way. Much of the universe is filled with enormous clouds of dust and gas. These clouds are the birthplaces of stars and planets, but they often block visible light, making it difficult for ordinary telescopes to see what lies inside. Webb was designed to observe a different kind of light, a form of light called infrared. You cannot see infrared light with your eyes, but you experience it every day. When sunlight warms your skin on a cool afternoon, part of that warmth arrives as infrared radiation. When a stone pathway remains warm after sunset, it is gently releasing infrared energy into the air. Webb uses this invisible light to peer through cosmic dust and uncover regions that would otherwise remain hidden. It is a bit like exploring a dark forest with a lantern that reveals paths invisible to ordinary sight. To accomplish this task, Webb had to become one of the most sophisticated observatories ever built. Its primary mirror stretches more than 6 meters across, making it far larger than Hubble's mirror. The mirror is composed of 18 carefully engineered segments that work together as a single reflective surface. If Hubble was a powerful eye, Webb became something closer to a giant cosmic light collector. But size alone was not enough. Infrared light is closely associated with heat. Even the warmth generated by the telescope itself could interfere with its observations. So Webb had to remain extraordinarily cold. To help achieve this, engineers equipped it with a massive sun shield roughly the size of a tennis court. This shield blocks heat from the sun, earth, and moon, allowing the telescope to remain in deep cold while observing the distant universe. Webb also operates far from Earth. It resides approximately 1.5 million kilometers away at a special gravitational balance point where it can maintain a stable position relative to our planet and the sun. From there, it quietly watches the cosmos, shielded from much of the heat and light that could interfere with its mission. Yet all of this engineering serves a remarkably simple purpose: to see farther, and therefore to see earlier. One of the most extraordinary facts about the universe is that light does not travel instantly. Even moving at an incredible speed, it still requires time to cross vast cosmic distances. The oldest light captured by Webb began its journey billions of years ago, long before Earth existed, long before the sun formed, long before our solar system emerged from its cloud of gas and dust. When Webb observes these ancient galaxies, it is seeing them as they appeared near the beginning of cosmic history. In some cases, only a few 100 million years after the Big Bang. To put that into perspective, imagine compressing the entire history of the universe into a single calendar year. The galaxies Webb observes would appear during the first days of January. Human civilization would not arrive until the final moments before midnight on the last day of December. Webb is allowing us to glimpse a universe that was still in its infancy. A universe where the first stars were illuminating the darkness, where galaxies were assembling themselves from vast clouds of matter, where the structures that would eventually become cosmic cities were only beginning to emerge. Yet some of Webb's most exciting discoveries were not the ones astronomers expected. Before Webb launched, many researchers believed the earliest galaxies would be small, faint, and relatively simple. After all, they had not existed for very long. But when Webb began sending back images, something surprising appeared. Some early galaxies seemed brighter than expected. Some appeared larger than expected. Some appeared more mature than expected. It was as though astronomers had opened an old family photo album expecting to see toddlers, only to find young adults staring back at them. The universe appeared to have grown up faster than many theories predicted. Scientists are still working to understand exactly what these observations mean. Perhaps the earliest galaxies formed stars more efficiently than expected. Perhaps our models need adjustment. Or perhaps the universe still holds secrets we have not yet imagined. This is one of the beautiful things about science. The most advanced instruments are not built to confirm what we already know. They are built to reveal what we do not know. And Webb has already done exactly that. It has shown us ancient galaxies, hidden stellar nurseries, distant planetary systems, and mysteries that continue to challenge our understanding of cosmic history. The deeper it looks into the universe, the more it reminds us that discovery is never truly finished. Because every new image is not merely a picture, it is a message carried across billions of years, a fragment of ancient history arriving at last. And among those messages are some of the most beautiful sights ever captured by human instruments, places where stars are being born, where old stars are dying, and where entire galaxies dance through space together in enormous cosmic gatherings. Those remarkable landscapes would soon become some of the most iconic images of the James Webb Space Telescope. One of the most remarkable things about the James Webb Space Telescope is that it does not only look farther into the universe, it also helps us see familiar cosmic processes in entirely new ways. After all, the story of the universe is not simply about distant galaxies and ancient history. It is also a story of birth and death, of beginnings and endings, of matter endlessly changing form as billions of years pass. Some of Webb's most famous images reveal these processes with extraordinary clarity. Among them is a breathtaking region known as the cosmic cliffs. At first glance, the image appears almost earthly. Many people compare it to a mountain range illuminated by sunlight. There seem to be towering cliffs, valleys, ridges, and peaks stretching into the distance. But these are not mountains. They are enormous walls of gas and dust located within the Tarantula Nebula, a vast stellar nursery where new stars are constantly being born. The scale is difficult to comprehend. The structures in the image rise across distances so large that light itself would need several years to travel from one side to the other. If you could somehow stand nearby, the scene would not resemble a mountain range at all. The material would be incredibly thin, far thinner than even the emptiest vacuum chambers on Earth. Yet when viewed across immense distances, these delicate clouds create landscapes of astonishing beauty. Inside these clouds, gravity slowly gathers gas and dust together. Over time, small concentrations become larger. Larger concentrations become denser. Eventually, some regions become so compressed that new stars ignite deep within the darkness. For most of human history, much of this activity remained hidden. Visible light struggled to pass through the dense clouds. But Webb's infrared vision allows us to peer beneath the surface. It is a little like discovering that a quiet hillside is actually filled with countless seeds already beginning to grow beneath the soil. What appears calm and still may secretly be full of activity. The same is true throughout much of the universe. Wherever there are clouds of gas and dust, new stories may already be beginning. Yet while some stars are just starting their lives, others are approaching their final chapters. One of Webb's most beautiful observations captures this reality in a striking object known as the Southern Ring Nebula. This glowing shell surrounds a dying star. For much of its life, the star quietly transformed hydrogen into heavier elements deep within its core. Over millions and billions of years, it released light and warmth into space. But stars do not shine forever. Eventually, many stars similar to our Sun begin shedding their outer layers. The material drifts outward into space, forming delicate glowing structures that can resemble petals, bubbles, or luminous clouds. Earlier telescopes showed this nebula as a beautiful object. Webb revealed far more. Its instruments uncovered hidden details within the expanding cloud, and even helped identify companion stars involved in shaping the nebula's appearance. But perhaps the most meaningful lesson is not what Webb saw. It is what the nebula represents. The death of a star is not simply an ending. The material drifting away contains ingredients that may eventually become part of future stars, future planets, and perhaps even future living organisms. The calcium in bones, the iron in blood, the oxygen we breathe. Many of the elements essential to life were forged inside ancient stars long before Earth existed. In that sense, every ending becomes part of another beginning. The universe is constantly recycling itself. A star dies. Its material spreads outward. New stars emerge from the remnants. New planets form. New possibilities appear. The cycle continues. Webb also turned its gaze toward one of the most active star-forming regions known to astronomers, the Tarantula Nebula. Despite its somewhat intimidating name, this immense cloud is not a place of destruction. It is a place of creation on a grand scale. Within its vast structure, countless stars are forming. Some are enormous, far larger than our sun. These giant stars burn brightly and live relatively short lives, flooding their surroundings with intense radiation and powerful stellar winds. By studying regions like the Tarantula Nebula, astronomers gain insight into a period of cosmic history, sometimes called cosmic noon. This was an era billions of years ago when the universe was producing stars at an extraordinary rate. If the history of the cosmos were compared to a single day, cosmic noon would be something like the bustling activity of midday. Galaxies were busy building stars. Black holes were growing rapidly. The universe was alive with creation. Webb allows us to study environments similar to those conditions and better understand how galaxies evolved during their most productive years. But stars are only part of the story. Galaxies themselves also change over time, sometimes slowly, sometimes dramatically. One of Webb's most famous observations focuses on a group called Stephan's Quintet. At first glance, it appears to be a peaceful gathering of galaxies. Yet appearances can be deceptive. Several of these galaxies are interacting through gravity, slowly influencing one another over millions of years. Stars continue their journeys, but entire galactic structures begin to shift. Gas clouds collide. New stars are born. Matter spirals toward giant black holes hidden in galactic centers. These encounters unfold far too slowly for humans to witness directly. Yet by observing different galaxies at different stages, astronomers can piece together the story, like studying photographs from different moments in a person's life. And then there are the deepest observations of all. Webb's deep field images reveal countless galaxies scattered across immense distances. Some are relatively nearby in cosmic terms. Others are so distant that their light began traveling toward us near the dawn of the universe. Every tiny point in these images represents a galaxy. Each galaxy contains stars. Many stars host planets, and every one of those worlds exists within a story of its own. When viewed together, these observations reveal a remarkable truth. The universe is not static. It is not frozen. It is not silent. Across every scale, from newborn stars hidden within dusty clouds to vast collections of galaxies drifting through space, change is always occurring. Stars are being born. Stars are dying. Galaxies are evolving. New mysteries are emerging. And through Webb's remarkable eyes, humanity has gained a deeper appreciation for this endless cosmic transformation. Yet before Webb began uncovering these astonishing details, another telescope had already changed the way we see the universe forever. Its discoveries would prepare the path that Webb now follows, extending humanity's vision into the deepest darkness ever explored. Long before the James Webb Space Telescope began sending back its remarkable images, another observatory was quietly changing humanity's understanding of the universe. Today, Hubble is often remembered as a scientific legend. Its images appear in textbooks, documentaries, museums, and classrooms around the world. But its story began with uncertainty. When the Hubble Space Telescope launched into orbit around Earth in the spring of 1990, expectations were enormous. For decades, astronomers had dreamed of placing a telescope above Earth's atmosphere. From the ground, even the clearest night sky presents challenges. Air currents blur distant objects. Tiny fluctuations in temperature distort incoming light. Looking through the atmosphere is a little like trying to admire a landscape through gently moving water. A telescope in space would avoid those problems entirely, or so everyone hoped. Then came the surprise. Shortly after launch, scientists discovered that Hubble's primary mirror contained a tiny flaw. The error was incredibly small, measured in fractions of the width of a human hair. Yet, in astronomy, even a tiny imperfection can have enormous consequences. The images arriving from space were blurrier than expected. For a moment, one of the most ambitious scientific instruments ever built seemed to be in trouble. Fortunately, this would become one of the most remarkable recovery stories in the history of exploration. Astronauts traveled to Hubble and installed corrective optics, essentially providing the telescope with a pair of carefully designed glasses. The repair worked. Almost immediately, the universe became sharper, and what Hubble revealed would transform astronomy forever. At first, many of its observations focused on nearby objects, nebulae, star clusters, galaxies. The telescope captured extraordinary details that had never been seen before. Towering clouds of gas, newborn stars, exploding stellar remnants, immense structures stretching across the cosmos. Among its most famous images was a region known as the Pillars of Creation. 3 towering columns of dust standing within the Eagle Nebula. The image looked almost like a landscape carved by wind and time. But those giant structures were actually stellar nurseries, places where new stars were forming deep within the darkness. For many people, this image became their first glimpse of how beautiful and dynamic the universe truly is. Yet one of Hubble's most important discoveries began with what seemed like an unusual request. A group of astronomers proposed pointing the telescope toward a tiny patch of sky that appeared almost completely empty. There were no famous galaxies there, no bright stars, no obvious targets, just darkness. The proposal sounded strange. Some worried it might waste valuable observing time. Why spend days looking at nothing? Eventually, the observation was approved. Hubble stared at that tiny region for many hours, gathering every faint photon it could detect. When the final image arrived, astronomers were astonished. The empty region was not empty at all. Thousands of galaxies appeared. Spiral galaxies, elliptical galaxies, irregular galaxies, some nearby, some incredibly distant. The image became known as the Hubble Deep Field, and it changed the way humanity viewed the cosmos. Imagine standing on a beach and picking up a single grain of sand, then discovering that the grain contains an entire hidden world. That was the feeling many astronomers experienced. A patch of sky no larger than a tiny speck held thousands of galaxies. If one small region contained so much, how many galaxies might exist throughout the observable universe? The answer was far larger than previous estimates. The cosmos suddenly seemed even bigger and even more populated. Years later, Hubble pushed further. The telescope spent even more time observing another tiny section of sky. The result became known as the Hubble Ultra Deep Field. The image revealed nearly 10,000 galaxies. Some of them were among the most distant objects ever observed at the time. Looking at the image is a strange experience. Almost every point of light represents an entire galaxy, not a single star, not a single planet. an entire galaxy containing billions or even hundreds of billions of stars. The image can feel overwhelming, yet it also inspires a sense of wonder. The night sky, which appears sparse and quiet to our eyes, is actually filled with structures stretching across unimaginable distances. Hubble also helped astronomers use one of nature's most remarkable tricks, a phenomenon known as gravitational lensing. The concept sounds complex, but the basic idea is surprisingly intuitive. Imagine placing a clear glass marble on top of a photograph. The image beneath becomes distorted. Certain regions appear stretched or magnified. Gravity can produce a similar effect. Massive clusters of galaxies can bend the path of light traveling through space. As a result, distant galaxies hidden behind those clusters may appear brighter or larger than they otherwise would. In a sense, the universe creates its own natural magnifying glasses. Astronomers learn to use these cosmic lenses to observe objects that would normally be too faint to detect. This approach eventually became a major project known as frontier fields. Combining Hubble's observations with these natural magnifiers allowed scientists to peer deeper into cosmic history than ever before. One particularly remarkable result involved a distant star known as Arendelle. Its name comes from an old word meaning morning star. The light from Arendelle traveled for billions of years before reaching Earth. Without the help of gravitational lensing, the star would have remained invisible. Instead, humanity briefly caught sight of one individual star shining from an extraordinarily distant era of cosmic history. For generations, astronomy had focused largely on galaxies. Now, Hubble had helped reveal a single star from the deep past. It was a reminder that, even at immense distances, individual stories still exist. By the time James Webb launched, Hubble had already spent decades expanding humanity's horizons. It taught us that empty space is rarely empty. It revealed galaxies beyond counting. It helped measure the age and expansion of the universe. And it showed that every time we looked deeper, new mysteries appeared. In many ways, Hubble prepared the path that Webb now follows. One telescope revealed how vast the universe truly is. The other is helping us explore its earliest chapters. Yet while both observatories looked outward across billions of light years, another frontier waited much closer to home. Far beyond Neptune, in a region filled with ancient frozen worlds, the solar system preserved its own memories of a distant. As powerful as Hubble and Webb are, there is one thing even the greatest telescope cannot do. It cannot physically travel to the places it observes. For that, humanity must rely on spacecraft. And while many missions have explored the planets of the inner solar system, few have ventured into the cold, distant frontier beyond Neptune. This region is so remote that sunlight arrives only as a faint glow. The warmth that reaches Earth becomes little more than a whisper. Temperatures fall to extraordinary lows. The familiar worlds of the solar system begin to disappear behind you. Yet hidden within this darkness lies one of the most important archives in the entire solar system, a place known as the Kuiper Belt. To understand why this region matters, it helps to imagine a very old attic. Perhaps it belongs to a family that has lived in the same house for generations. Inside are forgotten photographs, worn notebooks, old toys, and objects that have remained untouched for decades. Most of the house has changed over time. Rooms have been renovated. Furniture has been replaced. People have come and gone. But the attic preserves pieces of the past. The Kuiper Belt serves a similar role for the solar system. It is a vast region filled with icy objects left over from the formation of the planets more than 4.5 billion years ago. These worlds are not entirely unchanged. Time has touched everything, yet many of them remain far closer to their original state than the planets nearer to the Sun. Earth has been reshaped by oceans, weather, volcanoes, and life itself. Mars experienced dramatic geological changes. The giant planets evolved through complex processes over billions of years. But many Kuiper Belt objects have spent most of cosmic history quietly orbiting in the deep freeze of space. They are among the oldest surviving relics of our solar system's childhood. For much of human history, nobody knew they existed. Even after Neptune was discovered in the 19th century, astronomers had only a vague sense that additional objects might be waiting farther out. The challenge was simple. These worlds are incredibly distant. They are also small, and they reflect very little sunlight. Finding them is a bit like trying to spot a dark pebble resting on a distant hillside at twilight. The objects are there, but they are difficult to see. It was not until the late 20th century that astronomers began discovering large numbers of these frozen bodies. What emerged was an entirely new region of the solar system, a broad population of icy worlds orbiting beyond Neptune. Some are only a few kilometers across. Others are much larger. Together they form a vast belt encircling the Sun. Among its inhabitants are some surprisingly famous worlds. The most well-known is Pluto. For much of the 20th century, Pluto was considered the 9th planet. Its discovery captured public imagination and introduced generations of students to the idea of a distant world at the edge of the solar system. But as more Kuiper Belt objects were discovered, astronomers began to realize that Pluto was not alone. In fact, it was part of a much larger population. Other large objects appeared: Eris, Makemake, Haumea, and many more. Some were similar in size to Pluto. Others possessed unusual shapes, unusual rotations, or unusual histories. The solar system suddenly seemed far more diverse than previously imagined. Rather than ending neatly at Neptune, it continued outward into a realm filled with ancient frozen worlds. The Kuiper Belt also helps explain another familiar visitor: comets. Throughout history, comets often inspired wonder, fear, and curiosity. They would suddenly appear in the sky, glowing softly and trailing luminous tails across the darkness. For centuries, people debated their nature. Today we know that many short-period comets originate within the Kuiper Belt. Occasionally, gravitational interactions alter an object's orbit. A frozen body that once spent billions of years in darkness begins a new journey toward the Sun. As it approaches warmer regions, ice transforms into gas. Dust and vapor stream away into space. A bright tail appears. What was once an invisible object at the solar system's edge becomes a spectacular sight, visible from Earth. In this way, the Kuiper Belt continually sends messages from the distant past. Comets are not merely visitors. They are ancient survivors carrying clues about the conditions that existed when the planets were first forming. This is one reason scientists care so deeply about these remote objects. They are not studying them simply because they are far away. They are studying them because they preserve history. Imagine finding an untouched recipe written hundreds of years ago, or opening a sealed time capsule buried by previous generations. The value comes from what has been preserved. The same principle applies here. The Kuiper Belt contains records of processes that occurred long before Earth developed oceans, continents, or life. Its objects formed from the same cloud of material that produced the Sun and planets. By studying them, scientists gain insight into how entire planetary systems come into existence, how small particles become larger bodies, how larger bodies become worlds, and how a seemingly chaotic cloud of gas and dust eventually transforms into a structured solar system. There is also something quietly humbling about this distant region. For many centuries, humanity believed the known planets represented most of the solar system. Then new discoveries revealed an entire hidden population beyond them, a reminder that nature is often larger than our assumptions. Even today, countless Kuiper Belt objects remain undiscovered. Many are too faint for current surveys. Others may be waiting silently in regions that have not yet been thoroughly explored. The map is still incomplete, and that incompleteness makes the region feel strangely alive. Not because it is changing rapidly, but because discovery is still unfolding there. The Kuiper Belt is more than a collection of icy rocks. It is a frozen archive, a cosmic attic, a library preserving some of the oldest surviving chapters in the history of our solar system. And eventually, humanity decided that simply observing these distant relics from afar was not enough. A spacecraft would travel there. It would visit Pluto, then continue even deeper into the darkness. And in doing so, it would reveal that these ancient worlds were far more fascinating than anyone had imagined. By the beginning of the 21st century, Pluto remained one of the solar system's great mysteries. Astronomers had studied it for decades through telescopes on Earth and in space. They knew its orbit. They estimated its size. They could detect hints of its atmosphere. But Pluto itself remained little more than a blurry point of light. Imagine trying to understand an entire country by looking at it from the window of an airplane flying thousands of kilometers away. You might see shapes, you might notice colors, but the details that bring a place to life would remain hidden. That was Pluto for most of human history, a distant world, a tiny light, a mystery waiting to be explored. To change that, NASA launched a spacecraft called New Horizons. Its mission was ambitious: travel farther than any planetary exploration mission had gone before, cross billions of kilometers of space, reach a world that no human-made object had ever visited, and reveal what truly existed at the edge of the known solar system. The journey itself required patience. New Horizons traveled for nearly a decade before reaching Pluto. Year after year, it moved through the darkness. The planets of the inner solar system gradually faded behind it. Even Jupiter, which provided a valuable gravitational boost early in the mission, eventually became a distant memory. Ahead waited only the cold and quiet frontier beyond Neptune. Then, in the summer of 2015, humanity finally arrived. As New Horizons approached Pluto, the blurry dots slowly transformed. First came rough shapes, then brighter regions, then astonishing details. What emerged was not the frozen, inactive world many scientists had expected. Instead, Pluto appeared surprisingly alive. Not alive in the biological sense, but alive with geology, alive with change, alive with complexity. One of the first great surprises was a vast, bright region shaped somewhat like a heart. This feature quickly captured public imagination and became one of the most recognizable landscapes in planetary science. Scientists call it Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. The heart-shaped plane turned out to be far more than a beautiful landmark. It revealed evidence of active processes occurring on Pluto's surface. Within this region lies an enormous basin filled with frozen nitrogen ice. At first glance, ice may seem static, something fixed and unmoving. But on Pluto, this ice behaves differently. Over long periods, it can slowly flow across the landscape, much like glaciers move across Earth. The motion is incredibly slow, far too slow for a human observer to notice directly. Yet the patterns left behind reveal that movement is taking place. The discovery was remarkable. Many researchers had expected Pluto to be geologically dormant. Instead, they found evidence that its surface was still evolving. New Horizons also revealed mountains, not small hills, but towering peaks rising several kilometers above the surrounding terrain. Perhaps even more surprising, these mountains appeared to be made largely of water ice. On Earth, water ice feels fragile. A warm afternoon can melt it. A season can transform it. But Pluto is so cold that water ice behaves almost like stone. In this frozen environment, mountains can be built from materials that would seem delicate elsewhere. The familiar becomes unfamiliar. The ordinary becomes extraordinary. As scientists continued analyzing the data, more surprises emerged. Layers of bluish haze were discovered in Pluto's atmosphere. Sunlight interacting with gases high above the surface created delicate atmospheric structures stretching upward into the darkness. For a world once thought to be little more than a frozen relic, Pluto suddenly appeared dynamic and complex. It reminded astronomers of a lesson that exploration often teaches. Nature rarely follows our expectations. Again and again, the universe proves more creative than our assumptions. Yet Pluto was only part of New Horizons' story. After completing its historic flyby, the spacecraft continued deeper into the Kuiper Belt. Its next target was an object known as Arrokoth. Compared to Pluto, Arrokoth is much smaller. It lacks dramatic mountains. It lacks a substantial atmosphere. And yet it may be one of the most important worlds ever visited. Before New Horizons arrived, scientists knew very little about it. Even its shape remained uncertain. Then the spacecraft provided humanity's first close view. What appeared was unlike anything previously explored. Arrokoth resembled two gently joined lobes connected together. Some people compared it to a snowman. Others saw two pebbles resting side by side. Its unusual appearance provided a valuable clue about how planets may have formed long ago. For many years, researchers debated exactly how small objects in the early solar system grew into larger ones. One possibility involved violent collisions occurring repeatedly over time. Another possibility suggested a gentler process. Small particles drifting together, gradually collecting, slowly accumulating material, like snowflakes settling onto a growing snowbank. Arrokoth seemed to support this quieter picture. Its structure suggested that its components merged gently rather than crashing together at high speed. The object appeared to preserve a record from the earliest stages of planetary construction. In a sense, Arrokoth is not merely a distant object. It is a fossil, a surviving fragment from the era when worlds were first being assembled, a message preserved for more than 4 billion years, waiting patiently in the darkness until a spacecraft finally arrived to read it. What makes New Horizons so remarkable is not simply the distance it traveled, it is the perspective it provided. Before the mission, Pluto was largely an idea. After the mission, Pluto became a place. Before the mission, the outer solar system seemed cold and inactive. After the mission, it became a landscape of surprising complexity. Before the mission, objects like Arrokoth were little more than faint points of light. After the mission, they became tangible pieces of cosmic history. And yet, even as New Horizons continued its voyage through the frozen frontier, two older spacecraft were already much farther away. For decades, they had been traveling beyond the planets, carrying humanity's curiosity toward a destination no mission had ever reached before. Their names were Voyager 1 and Voyager 2, and their journey would eventually carry them beyond the influence of the Sun itself. Long before New Horizons began its journey toward Pluto, two spacecraft had already embarked on one of the most ambitious expeditions in human history. Their names were Voyager 1 and Voyager 2. Even today, nearly half a century after launch, they remain among the greatest explorers humanity has ever built. What makes their story remarkable is not only how far they traveled, it is how unlikely the opportunity was in the first place. During the 1970s, astronomers realized that something extraordinary was about to happen. The giant planets of the outer solar system, Jupiter, Saturn, Uranus, and Neptune, were approaching a rare alignment. This arrangement occurs only about once every 176 years. For a brief window in time, a spacecraft could visit multiple giant planets using their gravity to gain speed and change direction. It was a little like finding a series of perfectly placed stepping stones crossing a wide river. Miss the opportunity, and the path disappears for generations. NASA decided to take advantage of this rare celestial arrangement. Two spacecraft were built. Two journeys began, and together they would transform our understanding of the outer solar system forever. One of the most elegant parts of the mission involved a technique known as a gravity assist. The concept sounds complicated, but the basic idea is surprisingly simple. Imagine a child running alongside a moving carousel. If they grab the edge at just the right moment and release again, they can gain speed from the carousel's motion. A spacecraft can do something similar when passing near a planet. As it swings around the planet, gravity alters its trajectory and effectively transfers a tiny amount of the planet's orbital energy to the spacecraft. The planet barely notices, but the spacecraft receives a valuable boost. Using this technique, Voyager could travel far beyond what its fuel supply would otherwise allow. Its journey became a masterpiece of celestial navigation. The first great destination was Jupiter. Even before Voyager arrived, Jupiter was known as the largest planet in the solar system. Yet nobody fully understood how active and complex its system truly was. As the spacecraft approached, it revealed details unlike anything previously observed. Among the most astonishing discoveries was a moon called Io. At first glance, Io appeared unusual. Its surface displayed strange colors and patterns. Then scientists noticed something even more remarkable: volcanoes. Not ancient volcanoes preserved from the distant past. Active volcanoes erupting in the present. It was the first time active volcanism had been observed beyond Earth. Giant plumes rose above the surface. Molten material erupted into space. Entire landscapes were being reshaped. The discovery surprised scientists around the world. Until then, many had assumed that small moons would be cold and geologically inactive. Io shattered that assumption. The universe, once again, proved more imaginative than expected. Another moon quickly captured scientific attention: Europa. Unlike Io, Europa appeared smooth and bright. Its icy surface was covered with long cracks and dark lines stretching across vast distances. These markings hinted at something hidden below. Scientists began to suspect that beneath Europa's frozen shell might lie a global ocean, a vast body of liquid water concealed beneath the ice. Voyager did not prove the ocean existed, but it provided the first compelling clues. Decades later, Europa would become one of the most important targets in the search for environments that might support life. From Jupiter, Voyager continued onward to Saturn. Few sites in the solar system are as iconic as Saturn's rings. Yet Voyager revealed details far beyond anything visible from Earth. The rings were not simple, solid structures. They were composed of countless particles orbiting together in intricate patterns. Some regions appeared braided. Others displayed gaps and waves shaped by the gravitational influence of nearby moons. The system resembled a vast cosmic dance, endlessly changing and rearranging itself. Saturn also introduced scientists to one of its most intriguing moons, Titan. Wrapped in a thick atmosphere, Titan concealed its surface beneath layers of haze. At the time, Voyager could not see through the atmosphere completely, but the discovery itself was extraordinary. Titan possessed a substantial atmosphere unlike most moons in the solar system. It would later become one of the most fascinating worlds ever explored. While Voyager 1 continued toward the edge of the solar system, Voyager 2 pressed onward toward destinations no spacecraft had ever visited. Years passed. The sun grew smaller. The darkness deepened. Eventually, Voyager 2 reached Uranus. This distant world immediately challenged expectations. Unlike most planets, Uranus appears tilted dramatically on its side. It rotates almost as though it had been knocked over long ago. Its magnetic field also behaved strangely, offset and tilted in ways scientists had not anticipated. The planet seemed calm at first glance. Yet beneath its quiet appearance lay mysteries that researchers are still trying to understand today. Then came the final planetary encounter, Neptune, the most distant major planet in the solar system. Many expected a cold and relatively inactive world. Instead, Voyager discovered powerful storms. One enormous atmospheric feature became known as the Great Dark Spot. Powerful winds raced through Neptune's atmosphere at astonishing speeds. Some exceeded 2,000 kilometers per hour. Even in the frigid outer reaches of the solar system, nature remained energetic and dynamic. Neptune's largest moon, Triton, delivered another surprise. Voyager observed towering geysers erupting from its frozen surface. Dark material rose upward before drifting across the landscape. It was one of the most unexpected discoveries of the entire mission. A frozen moon, billions of kilometers from the sun, was still active, still changing, still alive with geological processes. Again and again, Voyager encountered worlds that defied simple expectations. Volcanoes where none were expected, hidden oceans beneath ice, complex ring systems, strange magnetic fields, violent storms, active frozen moons. Each discovery reinforced an important lesson. Exploration is not merely about confirming what we think we know. It is about encountering realities we never imagined. Perhaps that is why Voyager remains so beloved. It carried humanity into unknown territory and returned with stories no one could have predicted. And when the tour of the giant planets finally ended, the mission itself did not. The spacecraft continued onward, far beyond Neptune, far beyond Pluto, toward a boundary that no human-made object had ever crossed. A boundary where the influence of the sun gradually fades and the wider galaxy begins. After Voyager completed its historic tour of the giant planets, many people might have assumed the story was over. After all, the spacecraft had already accomplished more than anyone originally expected. The mission had revealed volcanic moons, hidden oceans, giant storms, and entirely new views of distant worlds. By almost any measure, it was already a tremendous success. And yet, the most extraordinary chapter was still ahead. Because Voyager kept going, year after year, decade after decade. While new generations were born on Earth, the spacecraft continued its silent journey into the darkness. The planets gradually disappeared behind it. the sun became smaller, and the spacecraft approached a frontier unlike any it had encountered before. To understand this frontier, it helps to think about the sun in a slightly different way. Most of us imagine the sun as a giant glowing sphere hanging in space. And of course, that is true. But the sun is doing something else as well. It is constantly releasing a stream of charged particles that flows outward in every direction. This flow, known as the solar wind, travels far beyond the planets. In a sense, the sun is continuously breathing into space. Imagine standing outdoors on a windy day. Even without seeing the air itself, you can feel its presence. You notice leaves moving, grass bending, clouds drifting. The solar wind is somewhat similar. It is invisible to our eyes, yet it fills a vast region surrounding the sun. Over time, this outward flow creates an enormous bubble around our solar system. Astronomers call this bubble the Heliosphere. It is difficult to appreciate just how large this structure is. If the orbit of Earth were reduced to the size of a small coin, the heliosphere would still stretch across an enormous distance far beyond the outer planets. Everything we usually think of as the solar system exists inside this immense bubble. The planets, the asteroids, the comets, even the distant Kuiper Belt. All of them travel within the sun's extended sphere of influence. For decades, scientists wondered where this bubble ended. What would happen at its outer boundary? Would there be a sharp edge? Would there be a sudden transition? Or would the change occur gradually? Voyager was heading toward the answer. As the spacecraft moved outward, it eventually entered a region known as the Helios Heath. This is an area where the solar wind begins to slow down. Imagine a river approaching the ocean. The water does not stop instantly. Its behavior gradually changes as it meets a different environment. Something similar happens here. The solar wind pushes outward from the sun, but eventually it encounters material that already exists between the stars. The pressure from this interstellar environment begins to resist the sun's outward flow. The result is a broad transition zone, a place where two vast regions meet. For years, Voyager moved through this frontier. Scientists carefully monitored its instruments, watching for signs that the spacecraft was nearing the outer boundary. Then, after decades of travel, a historic moment arrived. Voyager 1 crossed the Heliopause. Later, Voyager 2 crossed as well. The Heliopause is often described as the boundary between the heliosphere and interstellar space. But it is important not to imagine a giant wall or a cosmic fence. There is no gate, no signpost, no dramatic line painted across the universe. Instead, the change is subtle. The influence of the sun gradually weakens. The influence of the galaxy gradually becomes stronger. The spacecraft simply moves from one environment into another, and yet the significance is enormous. For the first time in history, human-made objects entered interstellar space. The phrase sounds almost poetic. Interstellar space, the region between the stars. For generations, this place existed only in imagination. Now, humanity had reached it, not with people, not with giant starships, but with two patient robotic explorers launched in the 1970s. Perhaps even more remarkable, Voyager continued sending information back to Earth. Its instruments began measuring properties of the interstellar medium, the thin material that exists between stars. Although this region appears empty, it is not truly empty. Tiny amounts of gas, dust, magnetic fields, and energetic particles drift through the darkness. The densities are extraordinarily low, far lower than anything we encounter in everyday life. Yet these particles help shape the structure of our galaxy. They participate in the long cycle through which stars form, evolve, and eventually return material back into space. Voyager was now directly sampling this environment, collecting information no spacecraft had ever gathered before. One particularly fascinating discovery involved plasma waves. These waves move through the sparse material between the stars. Scientists converted some of the measurements into audio frequencies that humans could hear. The result was sometimes described as the sound of interstellar space, not sound in the ordinary sense, since space is far too empty for sound to travel the way it does through air, but a translation of physical processes into something our ears could experience. The recordings possess an unusual quality: soft whistles, gentle rising tones, almost like distant echoes drifting through an enormous cosmic ocean. They serve as a reminder that even the emptiest regions of space contain structure and activity. Meanwhile, the spacecraft themselves continue aging. Their power supplies slowly weaken. Their systems require careful management. Occasionally, engineers encounter unexpected problems. Communication itself has become an exercise in patience. Signals travel at the speed of light, yet the distances are now so immense that messages require many hours to make the journey. A question sent from Earth today cannot receive an immediate reply. Every exchange becomes a slow conversation across the darkness. And still, Voyager continues. The mission that was originally expected to last only a few years has endured for decades. The spacecraft have become humanity's oldest explorers, tiny machines carrying our curiosity farther than any other objects we have ever built. Their journey has also taught us something profound about scale. The solar system is far larger than most people imagine. Even after passing the planets, Voyager traveled for decades before reaching interstellar space. The distances are so vast that familiar measurements begin to lose meaning. Numbers become difficult to feel, difficult to visualize. Yet Voyager transforms those distances into a story measured not merely in kilometers, but in years of persistence, in decades of exploration, in a journey that continues even now. And as these spacecraft travel through the darkness between the stars, they carry something else with them. Not scientific instruments alone, not engineering achievements alone, but a small message from Earth itself. A message intended for whoever or whatever might someday encounter these distant travelers. By the time Voyager reached interstellar space, it had already transformed our understanding of the solar system. It had visited giant planets, discovered active moons, crossed the boundary of the sun's influence, and continued onward into the darkness between the stars. Yet one of its most powerful contributions to human history came not from a scientific measurement, but from a photograph. The story began in 1990. Voyager 1 was already billions of kilometers from Earth. Its primary planetary mission had long since ended. Before shutting down its cameras, astronomer Carl Sagan and others proposed one final observation. Turn the spacecraft around, look back, take one last photograph of home. From Voyager's immense distance, Earth was barely visible. The image that returned was almost shocking in its simplicity. Our planet appeared as a tiny point of light suspended within a sunbeam. Not a detailed world, not a globe with oceans and continents, just a faint blue speck, a pale blue dot. The photograph quickly became one of the most influential images ever captured, because it changed the scale of the conversation. From everyday life, Earth feels enormous. It contains mountains, oceans, deserts, forests, cities, and billions of people. Entire civilizations have risen and fallen across its surface. Wars have been fought, discoveries have been made, stories have unfolded across thousands of years. Yet from billions of kilometers away, all of it disappears into a single point. Every human who ever lived, every artist, every scientist, every explorer, every parent, every child, every dream and every memory, contained within a tiny dot floating in a vast cosmic darkness. The image did not make humanity seem unimportant. If anything, it suggested the opposite. It reminded us how rare and precious our world may be, how remarkable it is that a small planet orbiting an ordinary star became capable of looking back at itself. The pale blue dot became more than a photograph. It became a perspective, a gentle reminder that our differences often appear smaller when viewed against the backdrop of the universe. And yet Voyager carried something else beyond that photograph, something intentionally placed aboard the spacecraft before launch. A message, a time capsule, a greeting from Earth, known as the Golden Record. Attached to each Voyager spacecraft is a gold-colored phonograph record containing sounds and images chosen to represent life on our planet. The record was never intended as a realistic attempt to contact extraterrestrial civilizations. The distances are simply too vast. Instead, it serves as a symbolic gesture, a statement about who we are, a message placed in a bottle and released into the cosmic ocean. The contents are wonderfully human. Greetings spoken in many languages, music from different cultures, sounds of nature, waves breaking along a shoreline, birdsong carried through the air, the laughter of people, the heartbeat of life on Earth. Scientists, artists, musicians, and scholars work together to select material that might communicate something about humanity to an unknown future listener. Whether anyone will ever find the Golden Record remains uncertain. Perhaps it will travel forever, unnoticed. Perhaps it will eventually pass near distant stars. Perhaps one day, in a future almost impossible to imagine, another intelligence will encounter it. No one knows. But the existence of the record tells us something important. Human beings do not merely explore to gather information. We also explore to connect, to tell stories, to share experiences, to leave traces of ourselves beyond our own lifetimes. And Voyager's journey is far from over. Long after its instruments fall silent, the spacecraft will continue traveling through the Milky Way. Thousands of years from now, it will still be moving. Tens of thousands of years from now, it will still be moving. The spacecraft may outlast nations, languages, perhaps even many of the landmarks familiar to us today. Like a silent ship crossing an unimaginably large sea, it will continue drifting among the stars. Yet even as Voyager journeys outward, other explorers continue looking deeper into the cosmos. The James Webb Space Telescope is already uncovering mysteries that scientists are still struggling to explain. Some of the earliest galaxies appear larger than expected, brighter than expected, more mature than expected. The universe may have assembled its earliest structures faster than our current models predicted. Astronomers are actively investigating these questions, not because the observations are disappointing, but because surprises are often where science becomes most interesting. Every unexpected discovery opens a new door, and beyond those doors lie even deeper mysteries. Consider dark matter. Astronomers can observe its gravitational effects throughout the universe. Galaxies behave as though enormous amounts of invisible matter surround them. Yet nobody knows exactly what dark matter is. Then there is dark energy, a phenomenon associated with the accelerating expansion of the universe. It appears to influence the largest scales of cosmic structure, and yet its nature remains unknown. Together, these two mysteries seem to make up most of the universe, and still we do not fully understand them. Even the observable universe has limits. There is a maximum distance from which light has had time to reach us since the beginning of cosmic history. Beyond that horizon, we cannot currently see. Not because nothing exists there, but because information from those regions has not yet arrived. What lies beyond that boundary? More galaxies? More cosmic structures? A universe far larger than the portion we can observe? At present, nobody knows, and perhaps that uncertainty is fitting, because every generation of explorers has believed it was approaching the edge. Every generation eventually discovered another horizon waiting beyond. The sailors who crossed oceans found new continents. The astronomers who mapped planets found distant belts of icy worlds. The spacecraft that left the solar system found interstellar space. The telescopes that observed distant galaxies found even older galaxies beyond them. Again and again, the edge moved farther away. Perhaps the edge of everything is not a destination that can ever be reached. Perhaps it is something else, a direction, a question, a willingness to continue looking beyond the familiar. And so, as our journey gently comes to an end tonight, it is worth remembering how extraordinary this story truly is. A species living on a small world around an ordinary star has learned to send machines across the solar system to photograph planets from billions of kilometers away, to capture light that began traveling before Earth existed, to glimpse the earliest chapters of cosmic history, and to send a message into the darkness between the stars. The universe remains vast. Its mysteries remain unfinished. Its horizons continue to expand. But perhaps that is exactly what makes it so beautiful. Somewhere, far beyond the planets, Voyager is still traveling. Somewhere, deep in space, ancient light is still making its way toward Webb's mirrors. And somewhere beyond the limits of what we can currently see, new discoveries are waiting. For now, those mysteries can rest quietly among the stars. And perhaps you can rest as well. Thank you for joining this journey to the edge of everything. Wherever your thoughts may wander next, may they drift gently beneath the same universe that inspired explorers, dreamers, and scientists for countless generations. Good night.